Geometry lesson 2-4. All right, we've now been talking about logic and other different types of reasoning. We've got some different properties, different rules, and now we're going to start looking at proofs. Proofs is by far something that a lot of people struggle on, but you're not going to, because you're going to concentrate, you're going to practice, and even though it might be difficult, you're going to persevere through some of these more difficult ones. I'll try to go slow. I'll try to go step by step with some of the easy ones, and we'll first look at this example right here. Right? Solve and give reasons for any of the steps. Now, in the past in algebra, you could solve this relatively easy. This is not like a difficult problem. It's not the complexity of the problem that makes it hard. It's that you have to be able to explain what you're doing and why. Okay? So if we were to take this problem, and one of the things that we might do is we could say, we can change that to plus negative. Now in reality, I'm not going to write the step down for that, but if we wanted to be very thorough, we could say this. Maybe I will write the step. So we have 8x minus plus negative 18. Okay? The rule that allows us to do that is the additive inverse. So we can make a little note of that. We can say additive inverse. Okay? But if we didn't have that step, if we didn't put that in there, we just went from this basic premise here, the first thing you might decide is you're like, well, I'm going to try to get all the x's on one side. Alright, so maybe you subtract 3x from both sides. Alright, if you subtract 3x from both sides, you'll be left with 12 equals 5x plus that negative 18. But there has to be a reason for this step. So the reason you might say is, whatever you do to one side, you do to the other. And we subtract it on both sides. So that's called the subtraction property of equality. The subtraction property of equality. Equality meaning you kept things equal, we used subtraction, and we were doing it on both sides. That's what made it equal. Okay, next you might add 18 to both sides. So adding 18 to both sides now gives us 30 equals 5x. But again, we've got to have a reason for that. Now over here we subtracted. Now we're adding. So that's probably the additive, the addition property of equality. Again, I'm giving reasons for what's allowing me to do this. You might say, but I just want to solve it. Geometry doesn't do that anymore. Now we have to be able to explain why. And last, you would divide by 5. But because what we are doing on one side we must do to the other, we now know we have 6 is equal to x. This is the division property of equality. It's equality because we're doing it to both sides, but it's each one of the actions that we took. So to get from the start to the finish, I have reasons for each one of those. I'm doing them, I know all the math is correct, but these are the actual rules or laws that allow me to take those steps. Now I tried to give you an easy one, now it's going to get a little harder, and I'll try to explain this as well. So I'll give you, you want to write this down. Now this is just a line segment. A line segment that starts at A and goes to D. You got a B and a C in between. Alright? You will be given information, and then you'll have stuff that you're trying to prove. So here we have A to C is exactly the same as B to D. And what does that mean? That means that A to C is exactly the same as B to D. So the green section is exactly the same as the blue section. We are trying to verify that the distance A to B, which is here, is the same as the distance here. All we have are lines. That means there's not a whole lot of numbers in this. We've got to be able to use some of our logic. So I've gone through and I've got the step-by-steps. Alright? Now this is what we would call. Now remember I said some of the information is given to us. So here's my first statement. It's probably a good idea to start with information that you're given with, because you got to have a basis. So I'm starting with AC equals BD because that's what was given to me, and that's my reason I'm introducing it. I didn't just make it up, it was given. From there, I'm saying that the middle section, this right here, that's B to C, is equal to itself. You're like, what? Why? Of course. The reason I'm doing that is because if you look at this problem, the green part and the blue part, they kind of overlap. And the section where they overlap is right here in the middle. So what I'm trying to say is for both of the equations, for this side and for this side, they have that middle section in common, and that's why I'm saying it's equal. Now, the reason it's called reflexive property is because they're a reflection of each other. They're exactly the same. So anytime you write down something as the same as itself, that's the reflexive property. And you'll get used to these. Okay, now it starts to get a little bit more complex. Notice, I have the A to C here, and I have the B to D here. What's being subtracted from both of them? This value of BC. In other words, I'm taking this whole green section, and I'm taking the middle away. If I took the middle away from the green section, what would you have left? You'd have the chunk A to B. If I had this whole blue section and I took the middle away, what would I have left? I'd have the C to D. Is it okay to do it to both sides? Absolutely. That's called the subtraction property of equality. What you do to one, you must do to the other. I'm taking the exact same value right here away from both. How do I know they're the same value? Because I just got done saying up here they were the same value. So if I said B to C was 10, this would be AC minus 10, that'd be D minus 10. I'd be subtracting the same value from both sides. Okay, it gets a little bit more complicated now. So that's the beginning. Now, A to B, if you look back up here, A to B, that's this chunk, plus B to C, that's this chunk. That is equal to A to C. A to C. In other words, what I just got done writing down is the green line up there. So this part right here is representing the green line. And if you go from B to C, which is right here, and you add on to that C to D, which is right here, you're going to be left with B to D. And we know that's true because of the segment addition postulate. If you take one segment, add it to another, you get the whole thing. All right? I didn't just make that stuff up. That is a true postulate. Okay. Now, I made these color coordinated for a reason. See the blue AC minus BC? Here it is again. See the red BD minus BC? Here it is again. Okay? Now that may seem a little confusing. You're like, what? I have no idea what he did here. It has something to do with what I'm taking away from both sides. Here's AB. Here's AC. Here's AB. Here's AC. Look what happened. We subtracted BC from this side. If I wanted to get AB alone, I'd have to subtract BC from both sides. So here's what I did. It's right there. And notice, it's no longer on this side. Over here, if I wanted to get CD alone, I'd have to get rid of BC. How would you do that? The opposite of adding it would be to subtract BC. Oh, there it is. It's right there. I'm subtracting it. Okay? So I subtracted BC on both sides of this entire problem. That's why it's the subtraction property of equality again. Next, I use what we call substitution. And the reason, remember right back up here? I said those two were equal to each other. AC minus BC is equal to BD minus BC. Well, if those two are equal, that means that these two are equal. And if those two are equal, I should be able to take that chunk and put it right here. Now I have AB equals CD, which is the substitution property. And that, my friends, is what I was trying to verify in the beginning. Now that is complicated, and there's a lot of information here. It is not something that you will learn overnight. It will take us lots of practice. Okay? So I will try to go through this one more time. This is the given information. I know the middle chunk is equal to the middle chunk because of the reflexive property. Then, if I want to, I can take the middle chunk and I can take the middle chunk away from each end. That's why it says minus BC and minus BC. If I do that, I'm really focusing on the endpoints. That's what the endpoints are. Next, I talk about segment addition postulate, so that the two segments equal the whole. The two segments equal the whole. You'll notice there's that middle part again, BC. So I subtract the BC to get AB alone. I subtract the BC to get CD alone. Now it's alone. And I recognize something here. Those were the parts I had up here that were equal to each other. If that is equal to CD, then I should be able to replace the CD right here. Why can I replace it there? Because I just got done saying that they were equal. These two are equal. Substitution property. Alright, one more. Example number 3. A baseball diamond. Find the measure, missing the angle, find the measure of angle 4. Use the following information. The measures of angles 1 plus the measure of angle 2 plus the measure of angle 3 will equal 180 degrees. Also, the measure of angle 1 plus the measure of angle 2 is 93 degrees. So it's not a right angle, but it's close. I also know that the measure of angle 3 and angle 4 together make 180. So here's the diagram. Alright, I've got a whole bunch of information here. Let me try to just get this up. Here's the diagram. There we go. Now, these are all the angles that are labeled up above up here. And it's a baseball diamond, 90 feet to each one of the bases. Alright, we have the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. How do we know that? Because it was given. Got to start somewhere, okay? Next, the measure of angle 1 plus the measure of angle 2 equals 93. How do we know that? Again, it was given. Okay? The measure, 93 degrees plus the measure of angle 3 equals 180. Now that's a little tricky. How would we go about that? Measure of angle 1 and 2 makes 93. Here's a 93. So is that somehow incorporating all of this up here? Absolutely. What we're doing is we're saying, okay, if the measure of angles 1 and 2 are 93, right there is angles 1 and 2, there is angles 1 and 2, I'm replacing the measure of angles 1 and 2 with the value of 93. I'm taking that and plugging it in right there, and now I have 93 plus the measure of angle 3 equals 180. So what's that called when we plug something in for it? It's called the substitution property. So I substituted. I replaced what typically was the measure of angle 1 and 2 right here with that value, because that's what it's equal to. Okay? From that point, I now have the measure of angle 3 equals 87 degrees. And how did I get that? I subtracted 93 from both sides. So this is the subtraction property of equality. Because I subtracted 93 from this side to get measure of angle 3 alone, and I subtracted 93 from that side to get 87. So I now know the measure of angle 3 is 87 degrees. Alright, that's now a known fact of my problem. Next, the measure of angle 3 plus the measure of angle 4 is equal to 180. Where did that come from? That was also given. From there, once again, you'll see 87 is now in the place of the measure of angle 3, which is our friend, substitution. And what do you bet's next? Well, we'd like to find out what the measure of angle 4 is, and all of a sudden it's equal to 93. Why? Because we subtracted. We subtracted 87 from both sides, which is the subtraction property of equality. If you actually look through this problem, and I know it's difficult because you're not used to it yet, but you'll see a lot of stuff that's the same. I mean, look, 1, 2, 3 givens. That was just given information. The substitution property, replacing something. Subtraction property of equality, subtraction property of equality. Playing the shuffling game with subtraction to get a value alone. So we were able to answer the question, finding the measure of angle 4 with our logical argument. So I've given reasons for every step. The math is pretty sequential. There's no jumping steps. The idea of I'm not going to show my work, I'm going to do it all mentally doesn't fly anymore. Not with proofs. You have to be able to show the work.